So today, guys, we're looking at motion with constant acceleration. So the statement is that this is the simplest type of motion. Motion with constant acceleration is the simplest type of motion. Why? Because, as you may all be aware, calculus is not popular. Because the other motion, it means you have to apply calculus. You have to do dv/dt to get acceleration. And calculus was not popular. So the best motion becomes motion with constant acceleration, because in that case, when the acceleration is constant, the average acceleration and the instantaneous acceleration have the same value. So when you do dv/dt and when you just find average by saying v minus v naught over t minus t naught, or v final minus v initial over t final minus t initial, you get the same answers. So this is very easy to use. That's the reason why when you find statements, these ones you've already been doing, even when you're not sure that what we are using was motion with constant acceleration. So now, this one, the velocity changes at the same rate throughout. If you remember, acceleration is the rate of change of velocity with respect to time. So if that is the case, it means for this motion with constant acceleration, always the change in velocity with respect to time is always the same. It doesn't change at different instances. So those are the scenarios. There's a bar there. So that's a statement. The a bar is average acceleration. So you drop the bar because everything is all just acceleration. There's nothing like average, nothing like instantaneous. There's just average acceleration. So now a equals final velocity minus initial velocity over final time minus initial time. So we'll look at the stopwatch, guys. Like when you start your stopwatch, at the start of your stopwatch, that is the beginning of your observation. So that is your zero time. So that's the one we prefer to start with, such that the only time that we have is the time during the time interval. So the initial time becomes zero. Why? Because you are zeroing the time you're starting, so that the only time you get is the time of the activity. So that's what we have. So initial time is zero. Then initial velocity is v naught, the naught, N-O-U-G-H-T. The naught is another name for zero. It just means v when time is zero. So that's the initial velocity at t equals 0. Then the final velocity just becomes v. That's because you already have the initial velocity as v naught. So the final velocity just becomes v at any time that you're calculating. So the expression will always be a equals v minus v naught over t. So if a body starts from initial velocity v naught to a final velocity v in time t, the acceleration a is a equals v minus v naught over t. We love to make the equations linear. That's the reason why. That one that is highlighted, I don't know if that's pink or lilac. This one. I don't know what colors are there on your phones. That one is the first equation of motion, if you remember. I prefer not to write number 1, number 2, number 3. I just prefer that you know them, because I'll also add some equations. I was impressed with this question that was there. that a car starts from velocity 12 meters per second to the right, and the acceleration to the right is 6 meters per second squared, positive acceleration, meaning it's not slowing down. So if something is slowing down, then the acceleration is negative. To slow down is to retard. That's why we tell those people like ngade kuchusha umuntu, to say this, that's a retarded person. If someone is bothering you, your boyfriend doesn't give you time, he behaves like a child, then you say you are retarded, like a child. Because there's some guys out there and some girls out there who behave differently when they're with their friend. So what velocity will it have after 2 seconds have elapsed? The equation was just here, guys. This is your initial. To start is to have an initial. So the initial is 12 plus the acceleration is 6. Then the time is 2. I was surprised that some of you, though getting the correct questions, imupasira banama over t. No, why ukula kwatana ifema over t? We already have the equation, guys, of saying v equals v naught plus at. Why are you ukula vikama over? Davis ama over. Chose na mama yoba chose. Ama over yeka. Equation not mipela kare. It's just the one you are supposed to apply. Unless you should put ama over unless you're being asked to find the acceleration. There is this person who found 14. I'm sure he just missed out on writing the letters. He didn't see the 12, but everything he did was correct. Everything he did was correct. So now, the answer there we found correctly, all of us, was 24. Meaning we are going in the right direction. You guys have improved. I can see clear passes everywhere. You gave very good answers there. Keep it up. Mweba kachelo. From Faida Kachelo, Mulimaman, obviously. Tevium. So those are the things. So when we look at now the definition for average velocity, remember that when there's a bar there on top, like a line, like a dash on top there, then we're talking about average. So if something for a constant acceleration, there are only two velocities that are important, the initial and the final. Always, when you're given a question for constant acceleration, the only two velocities under consideration are the initial and the final. So since you only have two velocities, you remember average of, say, 7 things. You added those variables, those 7, and divided by 7. If you are given, say, 8 things, to get their average, you added all of them and divided by 8. If you are given 5, you do the same. You add all 5 and divide by 5. But now, for constant acceleration, we've said there are only two velocities, the initial and the final. So when you do v naught plus v over 2, then that is your average. Then that is your average. So these are the answers, guys, that you gave. This is powerful, including knowing a Daniel what's correct and correct. That's someone say 12 up are correct. So all of you guys, believe you me, let me confess, you are so sharp. I've never met a class this sharp. Okay? So now we've already said that average is v naught plus v over 2. So if you remember so well, guys, we also said that the average is displacement, which is delta x over t. The total displacement divided by the time interval was also average. Meaning, delta x is average times time. Delta x is average times time. So this expression, guys, V average times time equals V naught plus V over 2. So this expression, when you look at it, because Vt equals V naught plus V over 2 times T, it was in average, twaibula average. Twaibula, twaibika. I'm sure you've seen. So if you have this, guys, if you have this expression, average equals V naught plus V over 2 times T. E expression E, where we say now this is displacement. Displacement equals the average velocity times the time. Ila bombana in a expression, but you will not see it highlighted so much on the equations of motion. But it works in an event that you have the displacement, the time, and the final velocity. You can use it to find the initial velocity. If in the case that you have the initial velocity, the final velocity, and the time, you can use it to find the displacement. Remember always that displacement can also be written as x minus x naught. So that is the key reason in there. So now, if that is the case, we get this expression here, average, my money expression. Then we remember that this V from the first equation is equal to V naught plus AT. So we substitute. So if you've seen, instead of writing half, open brackets V naught plus V, we write half, open brackets V naught plus V naught again plus AT, because V naught plus AT is actually V. When you work this thing out, you come up with this equation of motion. Delta x equals V naught T plus half AT squared. Ila bomba, guys, ine. Then remember that in some equations, yes, sir, Mr. Moffat. Mr. Moffat.
Yes, so I'm asking what V naught is.
I said it's a velocity when time is 0, the initial velocity. Imamwalele mamusugu at you, if you V naught. I'm sure you can even see that. Apale bika V naught kandulo, epo tuwale bika you. Kataba Moffat. Can't you see? I'm expecting you to say, yeah.
Yeah, sir, I've seen.
Okay. So delta x equals x naught minus x minus x naught. So always remember that delta x is simply the change in position. I think we defined that. So now this displacement vector, when we work out, when you look at finding the area here, we discover that the area under the curve is always equal to V naught T plus half AT squared. V naught T plus half AT squared. This trapezium, when we work it out properly. So in short, don't you come up, what does it mean? Imwe, guys, for you to apply it, derive. So your job is just to say that the area under the graph of velocity versus time is always equal to the displacement. So if someone plots a graph, because so is like this, when motion is constant, when the acceleration is constant, you draw something, you end up with the shape of a trapezium. In some cases, if the acceleration is constant, if the acceleration is 0, you end up with a rectangle. But then in this case, we have the shape like this one. This one is a trapezium. Sometimes you can even just have a triangle. So the area, so very much for area of triangle, area of trapezium, we use that area for a velocity time graph. For your level, it's the most important graph for you to grasp. The velocity time graph for this one when it's constant. It's the most important thing for you to grasp. Position time graph is quadratic. I'm sure you did like grade 12, quadratic. So it's a quadratic. Then acceleration time graph is a straight line because acceleration is constant. So a straight line along the x-axis, along the y-axis, straight. So that's acceleration time graph. So you must know those things, guys. The next point is to go to the same, want to derive another equation. So we remember so well that delta x equals V average times time. And V average was that. Then the velocity, V average was half V naught plus V. Then we said V naught plus V is this. I'm sure you remember. V naught plus V is this. We remember it. So that's what average ili hapa in average. So now we are using this V naught plus AT. V equals V naught plus AT to change the subject to a formula to time. Want to create an equation, it equal to time. Because in an equation, like if you're given, it's not always that you're given the time. So what if you're not given the time? What equation do you use? It's this one. So we make the subject to a formula to t, the first equation here, V naught plus AT. We'll find V minus V naught over A. Then nga twabula e time twayita substitute pali e time eri apa. Then pali V average twabula ey'endaka e twabiika pona pena. We end up with this. When you work this thing out mathematically, you get this equation of motion. There are different ways. This one is the most nice to derive because there are so many different ways of deriving it. Some people would even prefer to square this part and square that in brackets. Then isolate out a part that includes the time and put it there. So those are the things. So guys, simply the equations are those. V equals V naught plus AT. Your job is just to know how to apply them. Delta x equals V naught t plus AT squared over 2 or half AT squared. V squared equals V naught squared plus 2 delta x. Or the last one, if you can see, this one was not in the textbook, but I've added it because it's very useful. Delta x equals V naught plus V over 2 in brackets times t, or simply delta x over t equals V naught plus V over 2. This is from average velocity. That Frendatos is from average velocity. So now, friends, if in the event that you are using x minus x naught, the expressions become that. If you've seen for these other derivations, what the 2,8, these are just the numbers of the equations. In fact, I should have removed them. The 2,8, 2,12, these are just equations to say this equation was derived where, so in a particular textbook. So ignore these 2,8, 2,12, 2,13, 2,14. Ignore this. But what I want you to know is that in this case, this equation, instead of using delta x, we're using x minus x naught. So remember that if the x naught crosses the equal sign, it becomes positive. So the equation becomes like this. X equals x naught plus V naught t. Ignore the x. It just means that V naught is on the x-axis. Plus half AT squared. Then this one is also V squared equals V naught squared plus 2a. The subscript x, guys, is just saying that the acceleration is along the x-axis. I should have deleted these. Then I said, let me give my students what they want. So a little bit of here. So when I give your friends muchungulo, na laugh me up efficiency. In fact, even on this very study master, I'll edit so that when you check the table, it makes sense to you. The subscripts just mean that this motion is on the x-axis. Why? Because there's also motion on the y-axis where the acceleration is constant and is equal to gravity. I'm sure you know that. Then apa x minus x naught ni chimona delta x, guys. Apa pachwa delta x na popene to be po x minus x naught. So that is the thing. In fact, these are the equations we apply the most, because in most cases we are looking for the final position or the initial position and just not the total displacement. So as you are drinking your cappuccino in your home, you put, as you are drinking your cappuccino or the iced tea, some of you is hot, so that whatever it is that you be taking, be it cappuccino, iced tea, a kasama, coffee, whatever it is that you'll be taking, you go through this question. So the idea is identify the equation by always listing the data you have been given. So you will say a motorcyclist heading east. East, remember, east, east. To you, when someone mentions east, that is the positive direction. So a car, a motorcyclist, uyu muntu ulensha Honda alea ku east, mambole kukabanga. So this person is going east, then he is passing through a small Katete town. Katete is a small town. We know there's a big city kudia, which is called Chipata, where people buy the nabakatundu muku kopwama selfie mumo. Baya lala pamo panch pale moneka wino. So something like a motorcyclist is moving in this small Katete town, then he accelerates at a constant, so you have your acceleration, you fish out acceleration. So you say A equals 4 meters per second squared. Why are you fishing out the data? So that you know which equation to use. Then after he leaves the city limits, the town limits, in fact, it should have been town limits. So at time t equals 0, he is 5 meters east. What that means, guys, is that the x naught, the position, the initial position, x naught is 5 meters. So write somewhere to say x naught equals 5 meters. Why are you sure that this is x naught? It is the position when time is 0. X naught is the position when time is 0. V naught is the velocity when time is 0. So you are told that at time t equals 0 is 5 meters east. And it is also moving east again at that time equals 0 at 15 meters per second. So meaning V naught, guys, is 15 meters per second. So the question is, find his position and velocity at time t equals 2 seconds. So you have your acceleration, you have your initial position, you also have the initial velocity. Then they ask you for the final velocity and the final position. Meaning you use separate equations. One, you use this one, this one, the second one, you use it to find the position. So you can write them on separate sides of the paper. Imbi on the other side. I'm sure you can see. Like Write them on separate sides of the paper where this one is written this side, the other one is written the other side. So that's the thing. So on a paper, do this side you do something, this side you do. So this side you do position, this side you do velocity. But some of you, I know, you love simple first and complex later. So you start with velocity on your left and position on your right. Why? Because position is a bit difficult. Muliko squared. And because squared kalengisha brain ya just a lock. So those are things. So you will find. So remember that these are simple because you only have one equation and three things, like there are four variables. 1, 2, 1, 2, 3, 4. So if you have four variables, you must be given 3 to find the fourth. So what you must be good at in this physics is to know how to change the subject of the formula. Ngakuli square d if yakubika square root y ishiba. When something crosses the equal sign, you remember the algebra that if it was positive, it becomes negative. If it was negative, it becomes positive. So that reasoning is very important. Then the last one, which is B, where is he when the velocity is 25 meters per second? Where is he when the velocity is 25 meters per second? So meaning the 2 seconds was just for A. So you discuss the 2 seconds. So you are going to have the final velocity, the initial velocity, the initial position. I'm sure you have. So you are looking for the final position. Which one do you use? You use this equation. Final velocity is 25. Initial velocity is 15. Then you have 2. The acceleration is 4. You open brackets. X is what you'll be looking for. X is the final position. Minus x naught, you put 5. Close the bracket. Then you change the subjects of the formula. For the first one, as we said, what is the position and velocity? V equals upon 15, the initial velocity is 15, plus the acceleration is 4 times 2. You have found the answer. Then x equals, for the position, x equals x naught is 5, plus v naught is 15 times 2, which is the time, plus half times half. Remember, if you want, you cannot write half. You cannot everything on top if then over 2. Half is to divide by 2. To half. Satuakane half half. So this is A. The acceleration is 4. The time t is 2 seconds times 2 squared. Yeah. So ngolefa kuchua kanza pona ka 2 squared wafumyapo ka squared kamuka 2 squared is 2 times 2. So kufumyapo times 2 imo na half ya lubanda kai. So those are the things. You do this, try it. If you really want, you can put the answers on your study master, my friends. There are 6 minutes remaining. If anyone has a question, you're more than welcome. Diva Changwe. Diva Changwe, is there a question? ITX Changwe. Tapadi question. Doris. ITX
Sir.
Doris. Yes?
Me?
You?
No.
No, what do you mean?
Which Changwe?
Yeah, I'm saying Doris.
Yeah, I'm confused. So
Oh, Changwe, I only asked if you had the question and you don't. Doris,
we'll post the answers.
Doris, raise your hand.
Sir, it's not a question but a request. I was kindly asking if you can be sending the links to your meeting 30 minutes prior to the commencement, because some of us have been missing the introductory parts.
Okay, go on YouTube. Go on YouTube and just get the introductory part. Everything I'm putting on YouTube. More from my word, Doris. Doris, have you read?
Okay, sir.
Sharp.
Yes,
Douglas?
sir.
Douglas,
Sir,
yes.
what does X represent? I'm asking about the X. What does X represent in these equations, sir?
Position. Coordinate position. Remember when we said
Meaning-
displacement?
Meaning distance.
Position, Tata. That's okay. Position is okay. But it's like distance, but position. What we mean is that's a coordinate on the x-axis. Like when we said displacement is a change in position. Meaning if it is moving, it is from 2 meters, that's your initial, and goes to 5 meters, that's your final. The displacement will be 5 minus 2, which is 3. So these are positions. Yes, you can think of them simply as distances on the coordinate system, because we're saying something is moving on the horizontal axis. So that's what the X represents. The X represents the coordinate movement, like on the x-axis, something is moving east. So it will move from 1 to 2 to 3 to 4 to 5 to 6 and so on. So that's a movement. So if you say at time t equals 0, it is 7 meters east, then you know that east is positive. Then you know that the initial position, which is x naught, is 7. Yes, Changwe, you've raised your hand now.
Yes, sir.
Yes.
Sir, this is a request. I was asking if you can put more work so we practice and we grasp the whole concept, because when we practice so like we put more exercises
mambo
or
okufinwa?
tasks that we can practice.
Mambo okufinwa.
Eh,
Bali olulimi olukali
kufinwa.
sana. Muli bamukitwe? Amushwani kukitwe.
Awe sadwa mdola.
Na mambo okusikopera bena kitwe mirandine. Moffat. Moffat, do you have
Yes,
another
sir.
question?
That's V naught squared.
V naught
Sir, V
squared.
naught squared, sir.
When we say V
Among
squared,
these, the data that we found.
okay. V naught squared y is the initial velocity squared. V naught is the initial velocity. X naught is initial position.
So V naught is 15 squared.
It's 15, yes, because it's time when time is 0. What is the velocity? And we're told that when time is 0 is 5 meters east. Have you seen 5 meters east? So if it is 5 meters east, then x naught is 5, and he is moving at 15 meters per second. So that means also that v naught is 15. So ngolefa okubika pali v naught squared nichwalabika po 15 squared, which will be, I think, 225, is it? What is 15 squared? You know. Guys, this has been a very progressive class.